Imagine your brain. What if it has thousands of tiny brains inside? What if that is the secret to how we think? This is a big question, a very exciting question. It is what a new book explores. The book is called 1,000 Brains. It was written by a clever scientist, Jeff Hawkins. Jeff has thought about brains for a long time. He wants to know how intelligence really works. His book shares a new idea about how our brain learns and how it makes us smart. Our brains are truly amazing things. Think about all you do each day. You learn new games, recognize friends, and imagine fantastic stories. All of this happens inside your head. But how does it do all this? That is the mystery Jeff Hawkins explores. This book is not just for scientists, it is for anyone who is curious. Anyone who has ever wondered, how do I think, or how do I learn new things? Jeff Hawkins explains them simply. So let's explore these ideas together. Let's find out about those 1,000 brains. The journey into our own heads begins here. Jeff Hawkins has an interesting idea. He says our brain is not one single thinker. Instead, think of the top part of your brain, the neocortex. This is the wrinkly, clever part. It is made of many tiny parts, thousands of them. Each tiny part works in a similar way. They are like little learning machines, all working together to make you. Imagine a very large library with thousands of tiny librarians. Each librarian looks after a few books. They all work in the same way. The neocortex in your brain is similar. It has many tiny sections called cortical columns. These cortical columns are like tiny brains. Each one is a complete system. It can learn and remember things. It gets information from your senses, like what you see or what you touch. There are so many of them, perhaps 150,000. That is a lot of tiny brains. This is where the book's title comes from. Your intelligence does not come from one place. It comes from all these tiny parts. They're all learning about the world. They share what they learn, and together they help you understand everything. It is like a giant team effort inside your head. How do these tiny brains work? Jeff Hawkins says they learn by building models. What is a model? Think of it like a small map. It is the brain's way of understanding something. Your brain makes a model for everything it knows. A model for a cat, a model for a ball. These models help you recognize things. Imagine you are learning about a cup. Your tiny brains, cortical columns, get to work. One column might learn how a cup feels. It feels smooth and hard and curved. It learns where the handle is. This column builds a touch model of the cup. Another tiny brain might learn by seeing. It sees the cup on the table. It sees its color, its size. This column builds a sight model of the cup. Your brain is full of these models, millions of them for everything imaginable. So these models are like little experts. Each cortical column becomes an expert on some small part of the world. It learns what to expect. This is how your brain builds knowledge, piece by piece, model by model. It is like putting together a giant jigsaw puzzle. Each piece is a model made by a tiny brain. This is the essence of learning. How does a tiny brain know about a cup's handle? How does it know where the handle is? Jeff Hawkins says the brain uses something special. He calls them reference frames. Think of a reference frame like a map. A special kind of map for objects. This map tells your brain where parts are. Imagine you have a toy car. It has wheels, doors, and windows. Your brain needs to know where these parts are. A reference frame helps with this. It is like an invisible grid. The brain places the car's features on this grid. Each cortical column, each tiny brain uses these. When it learns a model of something, it also learns the reference frame for it. This means it learns the object's structure. It learns how the parts connect. Without reference frames, things would be jumbled. Reference frames give objects their shape. They allow the brain to understand objects, not just as a bag of features, but as structured things. This is how you can recognize a cup, even if it is upside down. Reference frames are the brain's secret organizers. Section 5. Sensing the world, how we learn about a coffee cup. Let us think more about that coffee cup. How do your 1,000 brains learn about it? They use your senses, mainly your sense of touch and sight. Imagine you pick up a new cup. Your fingers explore its surface. They feel its roundness, its smoothness. They find the handle. Each touch sends signals to your brain. Many cortical columns get these signals. Each of these tiny brains or columns tries to learn. One column might focus on the curve of the cup. It builds a little model of that curve. Another column might learn about the handle. It uses its reference frame for the handle. This happens very fast. As your fingers move, new information arrives. Now think about seeing the cup. Your eyes look at it. Light bounces off the cup into your eyes. This creates signals sent to other columns. These columns are specialized for vision. They all build their visual models. The amazing thing is this: a column that learns by touch can understand the model built by sight. The 1,000 brains work together across senses. Section 6. Teamwork in your head. How we recognize things. So your brain has all these tiny models. Models of cups, cats, trees and words. Each model is stored in a cortical column or perhaps across a few columns. What happens when you see something new? How does your brain know what it is? Jeff Hawkins says it is like a vote. All the tiny brains get to participate. Imagine a furry thing runs past. Your eyes send signals to your brain. Many cortical columns become active. Each one has learned many models. One column might think, is it a dog? Another might think, is it a cat? Lots of columns shout out their best guess. The brain then looks for agreement. If many columns vote for cat, then cat becomes your perception. This happens incredibly quickly, usually before you're even aware of it. This voting or consensus is very robust. It makes your perception flexible and strong. Section 7. Thinking ahead, the brain as a prediction machine. These models in our brain do more than just recognize. They help us predict the future. Not in a magical crystal ball way, but in a very practical, everyday way. Jeff Hawkins believes this is key to intelligence. Our brains are constantly making predictions about what will happen next. This helps us prepare and act. Think about catching a ball. As the ball flies towards you, your brain is not just seeing it, it is predicting its path. This allows you to move your hand to the right place at the right time. This prediction comes from your brain's models. When you listen to someone speak, your brain predicts the next word. This helps you understand speech quickly. This constant predicting is a sign of learning. Thinking, then, is like making predictions and testing them against reality. Section 8. Why this matters. Understanding ourselves and building the future. Why is this 1,000 brains idea important? It helps us understand ourselves. It gives us a new way to think about how our own minds learn and perceive the world. This understanding can also help in education. If we know how the brain learns best, we can find better ways to teach. It could also help us understand conditions like autism or dyslexia. And then there is artificial intelligence, or AI. Jeff Hawkins' theory offers a blueprint, a way to build AI based on how the brain works. It shows that the secrets of intelligence are perhaps not so impossibly complex. Principles working inside your head right now, making you the smart person you are. Section 9. What will we discover next? Thinking about your own intelligence. So, we have explored a new idea, the idea of 1,000 brains, all working inside your neocortex. Each one a tiny learning machine, building models of the world. This is Jeff Hawkins' vision of how intelligence truly comes to be. It is a powerful and exciting way to think. This theory changes how we see the brain. It is not one big mysterious computer. It is more like a vast organized team. A team of simpler units working together in a clever way. The journey of discovery is ongoing. This new understanding opens many doors. What else will we learn about our minds? How will this knowledge change our lives? Every time you learn something new, your 1,000 brains are at work. The future of intelligence is not just in books or in laboratories, it is also in how you use your own amazing brain.